The National Fire Protection Association's response clarifies the relationship between the National Electrical Code, or NEC, and Webster's Collegiate Dictionary. Specifically, it addresses how to determine the appropriate edition of Webster's dictionary to use for defining terms that are not explicitly defined within Article 100 of the NEC. The key takeaway is that the edition of Webster's Collegiate Dictionary referenced in the NEC Manual of Style is the one that was in print at the time the specific edition of the NEC was developed and published. Therefore, for the 1999 NEC, the 10th edition of Webster's Collegiate Dictionary would be the applicable reference for undefined terms. This approach ensures that the definitions used are consistent with the context and understanding prevalent at the time the NEC was created. It is important to understand that this guidance is not a formal interpretation issued under NFPA regulations. It represents the personal opinion of the author and does not necessarily reflect the official position of the NFPA. However, it provides valuable insight into the intent behind the NEC and offers practical guidance for authorities having jurisdiction, or OJs, in their enforcement of the code. To elaborate on the process of interpreting the NEC using Webster's dictionary, it's crucial to consider the hierarchical structure of definitions within the code. Firstly, always refer to Article 100 of the NEC for definitions of terms used within the code. Article 100 provides the primary and authoritative definitions for electrical terms. Secondly, if a term is not defined in Article 100, then Webster's Collegiate Dictionary, specifically the edition in print during the NEC development, becomes a supplementary reference. Thirdly, remember that the dictionary is intended to provide general meanings of words as understood in common usage, not to override specific definitions provided in Article 100. It is also important to recognize the limitations of using a dictionary for interpreting technical standards like the NEC. The NEC addresses very specific electrical concepts, and a dictionary definition may not always capture the nuances or technical meaning intended within the context of electrical installations. In such cases, it may be necessary to consult other resources, such as industry standards, manufacturers' instructions, or expert opinions to fully understand the intent of the code. Furthermore, AHA should exercise caution when relying solely on dictionary definitions for enforcement purposes. It's essential to consider the overall context of the code, the specific application in question, and any relevant industry practices or interpretations. A rigid application of a dictionary definition without considering these factors could lead to unintended consequences or create unnecessary burdens on electrical contractors and installers. The purpose of the NEC is to safeguard persons and property from hazards arising from the use of electricity. This fundamental principle should always guide the interpretation and application of the code, including the use of external references like Webster's dictionary. It is not meant to be an overly burdensome application of common definitions, but a reasonable standard. When dealing with electrical systems, there are several critical concepts that are frequently encountered and often require precise definitions. Understanding these concepts is essential for safe and compliant electrical installations. Here are some key areas where clarity in definitions is paramount. Firstly, conductors and ampacity. Conductors are materials, usually wires or cables, that allow electrical current to flow. Ampacity refers to the current carrying capacity of a conductor, expressed in amps. The NEC specifies ampacity ratings for different types of conductors based on their size, insulation, and environmental conditions. Secondly, overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow, which could lead to overheating, damage, or even fire. The NEC mandates the use of overcurrent protection devices in electrical circuits and specifies the appropriate ratings for these devices. Thirdly, grounding and bonding. Grounding and bonding are essential safety measures that help to minimize the risk of electric shock and ensure the proper operation of electrical equipment. Grounding provides a low impedance path for fault current to return to the source, while bonding connects metal parts of electrical equipment to create an electrically conductive path. Fourthly, voltage and insulation. Voltage is the electrical potential difference between 2 points in a circuit measured in volts. Insulation is a non-conductive material used to prevent electrical current from flowing where it is not intended. The NEC specifies voltage ratings for electrical equipment and requires appropriate insulation for conductors and other components. Fifthly, enclosures and raceways. Enclosures are protective housings for electrical equipment, such as junction boxes, panel boards, and motor starters. Raceways are channels or conduits used to enclose and protect electrical conductors. The NEC specifies the types of enclosures and raceways that are permitted in different locations and applications. Sixthly, hazardous locations. Hazardous locations are areas where flammable gases, vapors, dusts, or fibers may be present, creating a risk of fire or explosion. The NEC has specific requirements for electrical equipment and wiring in hazardous locations to minimize the risk of ignition. Seventhly, equipment listing and labeling. The NEC requires that electrical equipment be listed and labeled by a recognized testing laboratory such as Underwriters Laboratories, or Listing and labeling indicate that the equipment has been tested and found to comply with applicable safety standards. Eighthly, wiring methods. The NEC specifies various wiring methods for different types of electrical installations, including conduit, cable, and open wiring. Each wiring method has its own set of requirements for installation and support. Ninthly, load calculations. Load calculations are used to determine the amount of electrical power that will be required by a building or electrical system. The NEC provides methods for calculating the load based on the size and type of the building, the appliances and equipment that will be used, and other factors. Tenthly, emergency systems. Emergency systems are electrical systems that are designed to provide power and lighting in the event of a power outage. The NEC has specific requirements for emergency systems, including the use of backup generators, automatic transfer switches, and battery backup systems. When interpreting and applying the NEC, it is essential to have a thorough understanding of these fundamental concepts and their associated definitions. Reliance on a dictionary should be used as a last resort when the terminology is not defined in Article 100. If you are unsure about the meaning of a term or the requirements for a particular electrical installation, consult with a qualified electrical professional or your local AHJ. Furthermore, consider the impact of technological advancements on the NEC. As technology evolves, new electrical products and systems are introduced, which may not be adequately addressed by existing code provisions. The NEC is updated every 3 years to incorporate these advancements and to address emerging safety concerns. It is important to stay current with the latest edition of the NEC and to be aware of any changes or additions that may affect your work. Similarly, consider the role of industry standards and best practices. In addition to the NEC, there are many other industry standards and best practices that can provide guidance on electrical installations. These standards may be developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, the National Electrical Manufacturers Association, or NEMA, or other industry groups. It is beneficial to be familiar with these standards and to incorporate them into your work where appropriate. When faced with a specific electrical installation challenge, it is often helpful to consult with other electrical professionals or to seek guidance from your local AHJ. AHJ are responsible for enforcing the NEC and other electrical codes, and they can provide valuable insights into the intent and application of the code. Collaborating with other professionals and seeking expert advice can help to ensure that your electrical installations are safe, compliant, and reliable. The NEC is a complex and comprehensive document that requires careful study and interpretation. By understanding the fundamental concepts, staying current with the latest updates, and consulting with other professionals, you can ensure that your electrical installations meet the highest standards of safety and quality. In conclusion, the NFPA's guidance on the use of Webster's Collegiate Dictionary in conjunction with the NEC highlights the importance of using the edition that was in print at the time of the NEC development. This approach ensures consistency and accuracy in interpreting terms not defined in Article 100. While this guidance is not a formal interpretation, it provides valuable insight for AHA and electrical professionals in enforcing and applying the NEC. The ultimate goal is to ensure electrical safety and compliance in all installations. Remember to always prioritize safety and consult with qualified professionals when in doubt.